Hello, you are all welcome to today's class. The question we have to treat is from the principle of remainder. So let's take a look at it. So what is the remainder when 25 factorial is divided by 10 raised power 7? Now, one thing to note is when you divide a number by the powers of 10, the remainder is always the power of 10. So for example, if you divide a number by 10, 10 raised power 1, the remainder will be the unit digit of the number. If you divide a number by 100, 100 is 10 raised power 2. The remainder will be the last two digits of the number. So here we are asked to divide 25 factorial by 10 raised power 7. So all we need to do is find the last 7 digits of 25 factorial, and that will be our answer. So we are not going to use a calculator for this question. So how are we going to find 25 times 24 times 23 times 22 times 21 down to 1, and then whatever figure we have will now determine the last 7? We don't really need to know what that figure is. So there's a concept to employ which uh, focuses our calculation to what we actually need to draw out from that particular product. So we start with the number of trailing zeros, this number we have. How many zero we end 25 factorial? That is what we want to determine now. So the number of zeros will be determined by the number of fives and the number of twos in 25 factorial. So we want to know the number of fives, number of twos, number of fives. How many twos are there in 25 factorial? The formula to use is 25 over 2 plus 25 over 4 plus 25 over 8 plus 25 over 16. The next one will give us a denominator that is greater than the numerator, so we stop here. How many twos here? This is 12 plus how many fours here? This is 6 plus how many 8 here? That is 3 plus how many 16 here? This is 1. So this gives us 22. So that means there are 22 twos here times. So we want to go ahead and find in how many fives do we have in 25 factorial. 25 factorial has how many fives? So we have 25 divided by 5 plus 25 divided by 25. So we stop here. This is 5 plus 1. So it has 6 fives. So the limiting factor to determine the trailing zero will be 5 now. So we say 5 raised power 6 times 2 raised power 6 times 2 raised power 16. So there we have 10 raised power 6. So the number we have 6 zeros. So that means we need to keep this, and then so we have determined this, so we need to keep 2 raised power 16. So we write out 2 raised power 16 here. So 2 raised power 16, we have used the prime number 2, we have used 5. It remains 3. So how many 3's are there in 25 factorial? So it will be 25 divided by 3 plus 25 divided by 9. So the next one will be 27, so we stop. How many 3's do we have here? That should be 3 times 8, 24. Okay. I leave out it is the quotient that is of interest to us. We leave the fractional part. Plus, how many nines are here? So that will be 2. So that will give us 3 raised power 10. So there are 10 threes here. So the next prime number will be 7. So how many sevens are there in 25 factorial? So we come here 25, 7 plus 7 raised to power 2 is 25. So this would be 3. So 3 times 7 is 21. 7, 7 raised to power 3. Okay, times. So the next prime number will be 11. So we want to know how many 11 are 11s are in 25 factorial. That is 25 divided by 11 plus the next one will be 1, 2, 1. So we stop. So that will give us 2. So we have how many 11? How many 11 in 25 factorial? That will be 2. So we have 11 squared. So the next prime number will be 13. So how many 13s do we have? That will be 13. So the next one is 17 So, so we have 17 here. So the next one is 19. We have 19 here. Then is 23. So we have 23 here. So all we need to determine now is the unit digit of this product. So how are we going to go about that? So there's a formula to use. So 2 raised to power, let's determine the unit digit of 2 raised to power 16. 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 unit digit is 8, 2 raised to power 4 unit digit is 16, 2 raised to power 5 unit is 2, the circle will start all over again. So it will continue on the pattern of 4. So 2, 4, by the time you continue to raise 2 to different powers, it will give us a pattern of, the pattern will repeat after 4 circles. So 16 is a multiple of 4. So the remainder, the unit digit of this particular, with 2 raised by 7 is 6. So let's determine the unit digit of 3 raised to power 10. So let's see. So if you raise 3, raised power 1 unit digit is 3. 3 raised power 2 unit digit is 9. 3 raised power 3 unit digit is 3 times 9 is 7. 3 raised power 4 unit digit is 1. So it repeats after a circle of 4, after a pattern of 4. So 10 divided by 4 will leave us a remainder of 2. So the unit digit here is 9. So times, so let's wipe this off. Let's wipe this off. The next one I want to determine is 7. 7 raised power 1, unit digit is 7. 7 raised power 2, unit digit is 9. 7 raised power 3. 7 times 9 is, that is, unit digit will be 3. So that means 7 raised power 3 unit digit is 3 times 11 raised power 2 unit digit will definitely be 1. So the unit digit of 13 is here is 3. Unit digit of 17 is 7. Unit digit of this is 9. And we have unit digit of this is 3. So 3 times 9 is 27. So times 7 times 3 is 21. 1 is of no effect. 3 times 9 is 27. And we have 6. So since we are looking for unit digits, is the unit digit of all these numbers that concern us. So 7 times 1 times 7 times 6 will give us 49 times 6. Unit digit of the two numbers. So 9 times 6 times 9 will give us 54. So the unit digit is 4. So since we have 10 raised to power 6 already, so the unit digit, the last digit to be 4 times 10 raised to power 6. So which will make that to be our answer. So hope you find this video helpful. So that will be all for today. So until we meet again next time, have a nice day. Bye bye.